So we're going to get started with our next panel. I'm Dylan Olivia Hunzeker. I'm the moderator. I'm currently a researcher at Stanford Future Digital Currency Initiative. And we're going to chat unlocking scalability one piece at a time. So today we have Deli Gong from Automata Network. We have Matthew Wang from Valence and Altan Tutar from Nuffle Labs. We're going to have a really lively discussion. So I'm just going to sit and we're going to get started. So why don't we actually begin by everybody introducing themselves, a little bit about their backgrounds, and then what your firm does.
Sure. Can you guys hear me? Yeah, OK. This is Deli. I'm the co-founder of the Automata. We've been building a lot of middlewares in the past using trusted execution environment. So lately, we're actually running a modular attestation layer, trying to get something called like proof of machinehood verified and uploaded on-chain, and people can verify it. So we've been actually building this since April, because we are now running everything as a kind of icon layer as an AVS. We have a couple of our partners who are using our stacks, like multi-provers over there. So yeah, it's really great to be here with great panelists over here as well. So yeah.
Yeah, nice to meet everyone. I'm Matthew, co-founder of Valence. We're still semi-selfish, but what we're essentially trying to do is build infrastructure for bringing model-driven workloads on-chain. So things ranging from data preprocessing, feature encoding, transformations to different flavors of model inference to data post-processing. All of that available from your smart contract by simply just calling simple functions. My personal background is in software engineering and ML research. Spent most of my professional career before this in quant finance.
Hey everybody, good to see a lot of friends here. I used to be at the NEAR Foundation before, just spun out of NEAR 3 weeks ago, so it's quite a new venture. But we're Nuffle Labs. I'm the co-founder. So we built two products. The first product is the NEAR DA layer. It's pretty much like a stateless smart contract built on NEAR that you can post data to. Actually, Henry, who's one of our partners, is here. They're using us on mainnet today. They're probably one of the top 20 blockchains on L2Boot today. And the other product we're seeing, obviously, DA is not enough. DA is not enough, actually. That's kind of the meme. We're building a AVS on top that does fast finality. What you can do is essentially dump all the sequences to NEAR. You can take, operators take that sequence, run a full node, or get the attestations, block header attestations from Infura, and then kind of run a node and provide state aggregation. So that's a second product we're building, which is essentially allows you to build cross-chain applications. Let's say Automata would use it to basically do something on their rollup, and you can interact with it on OP. So that kind of gives a rundown of what we're building.
OK, great. So I'm going to start with a question that has been on my mind, which is, I think we can all agree that modularity means designing a system in such a way that different components or modules can be developed, replaced, or upgraded independently without affecting the overall system. Why do you think modularity as a narrative in crypto has become so popular over the last 18 months? Let's start there.
Right. To be honest, I think it's driven by the market, because people saw the opportunities in many of the verticals. So for a rollup, you have a sequencer, prover. You have maybe a relay to do the paymaster for your smart contract transactions. And now with DA layer available, these are really new spaces. So naturally people want build their own solutions, and sometime along the way they might figure out, okay, I have a better way to do this. So I think it's become very natural for creators. So they think this is something that I can do. Maybe I have a better solution. I will just do it. So that's why we see a lot of competition going on in these different verticals. So I think that's basically the reason why modular is so popular, because it's so it creates so much rooms for innovations. Yeah.
I think if you think about modularity, the idea of modularity and composability has existed in software engineering for quite some time. It's not really new or unique to Web3. And I think when you scrutinize exactly its impact on Web3, it's very easy to tell why it's become so popular. It's because it's made infrastructure customizable, hot swappable infrastructure, so much more easy to build and access, right? As an example, if I wanted to build some rollup that had some custom DA where the DA was stored somewhere, or if I wanted to have a custom VM, these are all things that would make sense to tailor design infrastructure to suit certain use cases, right? Without, I guess, quote unquote modularity, you'd have to spin up the entire stack by yourself, figure out how to set up your rollup, have your own, or if it's an L1, have your own validator nodes, what VM you want to use, where you would store data, what the trust guarantees around each part of the stack are. Whereas nowadays, now that you have specialized blockchains, some that are designed to do data storage, some designed to do like settlement, you can kind of like hop on Conduit or Caldera, choose how you want to compose your stack, and just like launch a rollup instantly for whatever application you're building. And I think it's the fact that it's made so easy and accessible that we've seen this kind of Cambrian explosion of new rollups entering the ecosystem, which ultimately, going back to what Deli said, kind of led the market to kind of become very excited about this technology.
Yeah, I think like we started at Near with monolithic vision. So we had a pretty much built an L1 that's scalable with sharding. And one of the things that we've seen while the OP stack was taking off, and last year there was the base launch, we looked back and said, Ethereum's not going to scale on itself. It's going to become a settlement layer. And execution is going to move out of Ethereum. Why not just look at our tech stack and say, hey, what we can build for this sort of like growing ecosystem? So that's how we started. We started last year in August within Near, and said, hey, like what can we provide? Pretty much seeing the trends and looking future and saying, hey, this is something that we can build. And the other thing, I guess, like Matthew mentioned already, everything is modular within software design. You're using a certain API to do something. You're using a microservice in AWS, and you kind of will see the same sort of trend in pretty much like blockchain design. And it's great to be part of like taking what Near built over time with the sort of like its own data availability layer and providing that for people. And that's why we're just kind of like, hey, let's just build something cool here. And then if you build that, what do you build on top? It's been always the case of like modular design brings sort of fragmentation, and how do we solve that fragmentation problem in a very unique way? So that's how we came to the space.
So I'm going to build on that, Altan. So what are specific technical advantages to modularity versus monolithic, right? And I think we've listed a few of them, and I think that that's kind of like the question du jour of like crypto right now, because we're seeing Solana just blow up. We're seeing other monolithic chains doing really well, and I know that people have their own theses for why that will or will not sustain.
Yeah, owning your block space is the one, right? So basically, it's always been the case. I mean, when Near started, it just went through the same sort of evolution. And the second part is, I guess, like you basically, if somebody else is using another application somewhere, actually Near design is quite nice because you can eventually, with stateless validation, you can take all the apps that are like blowing up with transactions and split them on shard. And like we'll use the same sort of design in Nuffle, but essentially just like having that as owning that sort of block space and controlling that is very important. And then essentially there was an interesting discussion today actually about yesterday, an ag day about synchronicity versus asynchronous sort of model. We always went through this like asynchronous model is going to be a big important step, and kind of modularity fits nicely around there, where different blockchains have different VMs, and you can combine them differently in a very unique way with sort of like chain abstraction solutions that obviously Near protocol folks are still working on, and with the fast finale ABS that we're building.
Yeah, I think block space is definitely one of them, and having like your own sovereign kind of control over your own stack, right? And if you think about it, it's pretty straightforward. It's just customizability, right? I can have my own rollup. I can choose where I want to settle. I can choose where I want to store data. I can choose my own VM. It's like buying a new car, right? If I want to drive fast and race, I can get a nicer engine. If I want, more, I guess, space in the car, I can get, like a larger car, right? And the same idea kind of applies to rollups. And now you have all these specialized rollups that are designed to do specialized things. Every application can have their own rollup, and I think it's obviously kind of shed a lot of light on just how important chain abstraction is in the kind of like modular thesis, where sure, it's really cool that you have all these specific applications on customized infrastructure, but it really fragments and is detrimental to the user experience if they have to figure out, oh, what canonical bridge do I have to be using to kind of bridge tokens between these two chains, or how would I want to kind of like if I wanted to interact with multiple protocols, I gotta like do all these things and have multiple wallets, and it becomes difficult for the regular user to interact with all this. So definitely think, yeah, chain abstraction is quite important to kind of making sure that all of these specialized infrastructure rollups can live together in harmony.
Right. I think the question actually reminds me of the other panel I just did yesterday, also about like the modularity, chain abstraction. So I think it seems that we're entering some cycles. So if you look at before, we are it's always like fragmented. Then we figure out some way to aggregate to make sure it's accessible to users. If you look at like how we have also many layer ones back then, and also like when DeFi was booming, we have a lot of forks. Like that creates like fragmented liquidity as well. So eventually we have aggregator try to help user to like make it easy for user to access the liquidity. And now we are like into that stage again. We have rollups serving different purpose. It's really built for the biggest page I think for rollup is really it's nice that people can decide on their own stack. They can choose what they want for their particular applications, or even they can optimize for different aspects for their maybe security, more maybe latency, maybe performance. So so I think it's really essential that like coming back to the chain abstraction angle, it's right now the time for us to really figure out what's the interface that user wants. Is it really like that important for them to understand the difference between chains, difference between different wallets, or how you manage the keys? Or we should just go for like a way better interface. Look at what's happening in Web 2 right now. People are stop using like Google search. More and more people are start using like ChatGPT for stuff, right? So maybe this is perhaps the right way to go. We should like figure out a way for users to have better approach to access blockchains.
Are there other real-world examples of modularity improving efficiency and performance of blockchain networks? Like I know that you mentioned fragmentation because of DeFi, et cetera, but is there anything in recent memory that just someone could attach their thinking to so that they could understand this in a more concrete way?
You mean the perspective on like the performance and things, or you mean?
Yeah, exactly. Like a time when, like the data availability did. Yeah, right.
I think pretty good examples is on the execution layer, like when people are. Maybe I can also touch a little bit on the DA layer as well. So on the execution layer, I've seen some development on the parallel execution, right? Actually, we had this kind of discussion long before when when layer ones were trying to solve the scalability issue using sharding. But now we're coming back to that topic again because like we really think that a single thread model for execution is not enough. We really should like try to find a better way to do the parallelization. But I also remember that looking at the data on Ethereum, the parallelization factor isn't really that viable because like some analysis already showed that maybe you can at most parallelize by the factor of 2. Even reaching 3 is difficult because it's just not available. But I mean, this is already an improvement. Of course, on rollups, now you have other choices to use different VMs that might have better optimization at the execution layer. They have this kind of just-in-time execution components, so that so maybe more and more execution will just guide the better optimization time. Also on the DA layer, there are really different approaches and also different guarantees, like when the data will be available and how long the data will be stored. So these are the things I think that's already available and will eventually allow developer. I mean, actually, as a developer who's going to use these layers, they have to really understand what's the pros and cons and trying to figure out what's the best fit for their stack.
Yeah, I think a good mental model to have around modularity is to think about it as modules that you import and export, or some commodity that you import and export, right? As an example, if you're some rollup that settles on Ethereum, you are kind of importing security from from Ethereum, as a settlement layer, right? And you use kind of the Merkleized root that you post to Ethereum as a way to determine, okay, what is the canonical chain, and that's how you inherit security, right? When you post like DA to near DA or Celestia, you're essentially saying, hey, I trust you that this is the data that the block data that we have on our rollup, trust that you will store it and that it will be available when the nodes want to query this data and be able to access and re-execute transactions for increased verifiability, right? And what we're working on at Valence as well, as an example, the kind of like commodity we want to export is kind of model-driven compute, right? Being able to pre-process data, transform data, feed it through different models to get some results, offloading that computation from existing rollups that aren't tailored to do this kind of compute to our network that can essentially be this co-processor / engine for you and do all the heavy lifting. And that's kind of the module that we export to them, right? Or that's the good that we export, which is this sophisticated compute that is secured by again other blockchains such as a settlement layer and DA. And I think that's a good mental model to think about how you are able to kind of take the good things that certain blockchains are designed for and kind of have a best of all worlds type approach where you pick and choose and ultimately use these to your advantage.
Does that apply to real-world examples within blockchains or outside of blockchains, or both?
Both, but I would love like outside too.
Okay, yeah. So outside, I mean, it's pretty simple. Like in Industrial Evolution, like you basically had to split the production line into different specializations, and eventually people sort of like evolved to have that, right? For us, obviously, Deli and Matthew mentioned modularity in a space of like roll-ups, but I'll take it to the restaking example, right? I mean, restaking is quite the similar sort of like design space. You use the restake EAT to do something outside of Ethereum to pretty much like design a system to be able to do one thing. And that's what, like, leaving that DA aside, we're also working on something that does specifically fast finality for roll-ups to have access information for pretty much not pre-confirmations that a lot of people are talking about, more like using another external validator set that uses restate EAT to provide state attestation. So you see that example like coming from history where everything started modularized to Web 2, where AWS did the same thing, to pretty much now to new design spaces as well.
Cool. So we just talked a lot about chain abstraction. How do other modular systems other than Agoric incorporate chain abstraction into software architecture? Like, do your companies do that? Is that like a general blanket kind of term for what you're doing, et cetera? I mean, we are at Chain Abstraction Day, so.
Yeah, I think it's quite difficult. Actually, what we are doing is trying to be multi-chain, but we felt that it's pretty difficult to be chain abstractive. Simple reason is there's just so much difference like among different chains. Often you really have to think about if it makes sense for you guys to just support yet another stack for scalability or for market reason. But what we are doing, maybe I have a great example over here. We have a RPC product called Wang RPC. It actually helps users to protect their IP address when they're accessing the different like RPC endpoint. But the best we can do over there is just like simplify this kind of access like endpoint so that people can just access multiple like different networks from one single endpoint. But still, like if like when things come to like key management and stuff, they still need to like have their own way of doing that. But we do see like some development right now on like smart contract wallet, and even some layer 1 chain already support this. It's kind of like reduce the requirement and also reduce the like overhead on like user side to maintain the key, but still it's kind of difficult. Also, I've seen like things like passkeys, right? These are relatively available on mobile devices or even on laptops. It could be a new era for like people to like using it as a key to manage like your accounts across different chains. But it's just a matter of time, like when this like all the different chains can support the crypto scheme used by passkey. So far, I think not many chains have this support, but there's some changes over there. Yeah.
Yeah, no, I think as we've been kind of developing our MVP to DevNet to testnet, we've really starting to realize just how important chain abstraction is to really make our product kind of work well and interop well with other existing blockchains. And we kind of like consider it like compute abstraction a little bit internally, where our end users are not so much kind of like retail folks trying to move money around, but rather they're kind of decentralized applications that want to leverage the compute on our network. And we've been sitting down thinking about what makes sense, what kind of design decisions, integrations we should make to make this a universally accessible kind of piece of technology that can be leveraged by any blockchain anywhere, or even just in Web 2 as well. And I think the kind of primary ways we're doing that is, really straightforward, but just integrating every single kind of cross-chain messaging application, cross-chain messaging protocol that we can integrate with, building in like paymasters, building in like regular Web 2 HTTP style APIs, and having very uniform interfaces to make just like our software interop well with these protocols.
Yeah, this is an interesting question. So I actually run the Chain Abstracted podcast that's sponsored by Near. And when you ask this question to everyone, everybody has a different answer. So for Near folks, I'll start with Near. I'll go down sort of to Nuffle. That's chain signatures, is to be able to drive keys from a Near account to, let's say, an EVM account or anything, then to be able to sign a transaction with an MPC network. For us, it's a bit unique in a sense that when you give those state attestations, then other people can use that to build a multi-chain app, right? So in the front end, it actually using a couple of different chains, but the front end should just be like unified, even though the system is very asynchronous. So, but for some folks, right, like, I mean, if you go to Espresso and other ones that do shared sequencing, they will have a different answer. Like they would say, oh, we're building a shared sequencer, so that's kind of their chain abstraction. For Polygon folks, it's the AG layer that allows to do that. So there's a lot of teams that are working on different solutions. I don't think there's one answer to that. It's just like depends on what the developers are looking for.
Cool. How important do you think collaboration is among different modular / DA kind of layers? And would you say you're competitive, each of you are competitive to some of the biggest ones that aren't sitting on stage that we all know?
Yeah, it's a funny question. So we get asked a lot, like, are you guys competing with EigenDA? And just because we're in the Eigen ecosystem. The way we see this is very collaborative. So obviously, Near DA was the first thing the design space that we knew, so we built that. Eventually, what we'll do, for example, for our fast finale layer is to integrate other DA layers, right? So every system, we would prefer actually just using Near DA because everything is like in the same design fashion. But some folks will use different DA layers just by design and just by alignment with the different teams. So we basically start to kind of like build out and add, let's say, EigenDA, eventually Celestia or others to be able to, for everyone to run that and basically give those state attestations. So the other thing is, like, I guess it's more collaborative. Like modular design space allowed us to kind of like work with tier 1 teams. That wasn't the case before. So while we were actually at the BD team in the Near Foundation, layer 1s almost competed like to get those applications. We don't have that design anymore, we don't have that like sort of, the first thing that comes to mind is not competition, it's collaboration. And we see that with everyone that we work with, like EigenLayer, even with like Polygon folks that historically were kind of considered competitors. Now we work on things together.
Yeah, I mean, I think I'd be surprised if anyone kind of disagreed with the fact that collaboration is important for modularity, but the entire like kind of ethos of modularity is that it's only useful because you have collaboration, right? It's like a DA layer by itself is not particularly valuable. A settlement layer by itself is not particularly valuable. It's only valuable when you are able to take kind of the best of each stack and piece them together, right? And in that way, we need to kind of collaborate together in an intra-vertical fashion, I would say, primarily, to create just like abstractions and interfaces that are uniform and make sense and allow people to kind of piece these things together so they can pick and choose whatever stack or infrastructure they want to kind of create their roll-up. So yeah, I mean, at least as someone building a network, that's kind of how I've seen the space from the outside.
I would also add to that it's totally necessary to have a very large network effect for these things to work, and that requires collaboration for the state that Web3 is in right now. So,
you can. Yeah, actually, the tipping point is really like when there's a standard that people can really stick to. So then the competition became more, I would say, fair. But before that, it's really just kind of a wide space, like because like as a first mover, you don't really know like sometimes what's the customer want, right? So you really have to talk to them, get their requirement, and this kind of design often is driven by that. And then when like multiple players come in, people start having more collaborations. They will also start doing more user education so that their customer can have a better understanding on the stack they're building. And eventually there will be a standardization progress. So maybe a couple of DA will like just eventually work together to just figure out a common standard so that their upstream and downstream could just work more smoothly with them. Otherwise, there will be a lot of frictions.
Yeah, speaking of standards, what you said actually reminded me of a meme. I do completely agree that like having these standards makes sense, and it's quite important. But there's this like stickman meme that I saw that's like quite popular. Is like two people are having a conversation. One's like there are currently 14 different standards to do a certain thing, and then the person's like, no, this is crazy. We must create a standard that unifies all the standards. And then the last slide is kind of like, oh, there are now like 15 competing standards. And I think it's kind of an interesting way, if you apply that kind of thinking to what we've seen in the kind of modular ecosystem, you have all these like roll-ups, right? And now you have multiple players trying to do some degree of shared sequencing or aggregation, and now you have like all these different players trying to launch their own like ag layers of sorts, and you have many different competing standards, which I think is in some degree it's a good thing because it's a healthy amount of competition. People are always trying to improve and build better technology, but it's also just quite funny to point out that I do think collaboration is important, but you definitely see a lot of competition to try to kind of aggregate and create this like network effect for themselves as well.
What advice do you have to people trying to build in the modular space? I know this is general, but it's useful.
Yeah, I would to start, I would say I think. So as someone who's kind of like more recently gone into Web3 and have come from a more, I guess like software, tech, finance-focused industry, it's interesting to see how short of a half-life a lot of crypto companies have. It seems like every cycle, the kind of like companies that are around and are considered relevant, it's almost like a new set every time.
Yeah.
And in that way, I think one piece of advice that I constantly remind myself and I would give to people building in this ecosystem is, your technology and your infrastructure is only as strong as its weakest link. So I think it's important to choose the right partners that have withstood the test of time, have withstood like multiple cycles, and to keep the Lindy effect in mind, right? It's like because if you have some DA layer, if you have some settlement layer, or if you have some part of your stack that ultimately soon becomes unmaintained, becomes obsolete, or worst, potentially exploited or whatnot, then your stack immediately becomes vulnerable and susceptible to everything. So I think, yeah, choosing your partners, choosing what kind of infrastructure to include within your stack, I think is actually something extremely vital that a lot of existing players don't think too much about because oh, this person's giving me a grant, I'm going to build on them, right? That's like the kind of majority of the pull that I've been seeing in this space. So yeah, just something to keep in mind.
I think in general, I mean, the suggestion to the like new builders, no matter if you're building a stack or using the stack, is just you really have to understand the tech itself, whether it's truly helpful to you or you're just like getting aligned in some way, right? So on that, actually, you really have to spend a lot of time researching like different verticals. Also, like if you are deciding which vertical to enter, you probably have to really see like which stage you are at or what kind of stage this particular vertical is at. So if it's really early stage, you have a lot of risk because no one has explored this area. It might not like worth the risk of like just doing like spend capital or spend time on it to try to create a standard or even like create some market adoptions. Sometimes you could just follow a kind of do a follower approach. So you can just try to like find a space that there are already maybe one or two players, but there's still maybe your room, so you can get in and try to just find your particular edge like compared to them. So for users who are using this kind of modular stack, I think I agree with what Matthew said. So like some of the points, especially choosing the stack wisely, because like there will be a vendor locking risk. If you find that okay, you probably can't change it afterwards, then you should really like make the right commitment. Otherwise, it would be quite difficult for you to make any move after like market condition change also.
Yeah, so challenges, I think Matthew and Deli have been doing a great job here, just like looking and studying all these, because we've been friends for a while. But essentially understanding like, what do you need a roll-up for? And then saying like, you look at OP stack, you look at Arbitrum, you look at Zk Sync, Polygon, and understanding like, do I really need a optimistic roll-up, or do I need a ZK roll-up? A lot of folks can't afford, like if you're an early startup, can't afford a ZK roll-up currently. So they might just go on up with like an OP, sort of OP and Arbitrum stack. That's the one challenge on the technical side. And the other side is, I guess, like just understanding the security parameters of a system that you're using. So let's say for Near, for example, like we've been running for a while, so that's been kind of the security sort of pitch. But like understanding sort of what are the trade-offs I'm making if I'm using it one system or the another, or maybe if I'm using Ethereum itself versus other solutions. So there's always trade-offs as a founder, as a builder, and really understanding those parameters and making that decision accordingly.
Perfect. So any last kind of comments that we want to make? I think we're going to wrap up. Anything that we're excited about, or anything?
Yeah, I can just mention, I think we chatted with Deli yesterday about this as well. I think one thing people don't realize, like people think about chain abstraction as from a user experience perspective, but a lot of people don't realize the security assumptions that comes with, right? In our case as well, like if you're using rollup A to rollup B, what ends up happening if something happens on rollup A? So that's something to definitely think about, just like because a lot of things are built on multi-sigs, right? So like understanding the teams, building, it's trustless, but you're still building trust with some organizations, right? I mean, you trust OP sequencer and you trust like, everything. So still need to understand like these sort of security assumptions of chain abstraction is pretty important.
Yeah, something Dean always talks about is that like when something is modular, it's almost always less secure, and people just don't realize that. Yeah.
Yeah, I think like one thing is if you like zoom out and think about what the blockchain compute space will look like in not a year or two, but rather 5 years, 7 years, 10 years from now, I think throughout the past couple years, you've really seen this trend of like all these like applications coming on, like there have been a lot more applications being developed, and to support these applications and to support kind of new users, people have been developing customized infrastructure or their own rollups, right, to have their own like sovereign block space and whatnot. And I think in the next couple years, right, if we really want to see blockchain compute, if we really want to see decentralized applications slowly gain market share and take over, eventually be a competitor to our TradFi counterparts, we really do need a lot of kind of like customized infrastructure to do many different things, right? Infrastructure designed to do sophisticated compute, whether it's AI or ML or some degree of optimization, things like this, right? Convexical optimization for routing. A lot of these things could be very important for applications that are developed in a decentralized fashion. And to do that, we need, like a lot of players and people who want to build this stuff, both applications and infra. So ultimately, to make everything work together in a concerted fashion, I do think chain abstraction is going to be an increasingly important topic that people talk about, both from a user standpoint and from a developer standpoint, so people can leverage what's already been developed to kind of empower their use cases on the application layer.
Yeah, actually building chain abstraction is quite a fun journey, because along the way you find there's a lot of blockers, especially coming from like standards, coming from like some kind of incompatibility with layers. But I think as a developer, I think what you could do is just like speak the word out, like make sure that people hear you, and there will be changes going on. And sometimes you don't really have to build a perfect solution. You just need a solution that works maybe for over 50 of the chains or standards. Then along the way, there will be like other people joining you and trying to like work with you collaboratively and to figure out like what's the eventual like outcome or like the result of this. So yeah, it's going to be really interesting, and it's necessary as well.
All right. Well, thank you so much. This was a great panel. Thank you.
Thank you, guys.
Thank you.
Thank you.